This is called site swap notation, which was developed in America in the mid-1980s at various different institutions. It turns out, I think there are quite a few mathematicians who are also interested in juggling. And I think the reason is because there are so many patterns involved, and I will show you some of these patterns. And while I think of it, I should say that a lot of this talk and the results in this talk are found in this book, The Mathematics of Juggling, by Burkhard Polster, who's actually at, he's in Melbourne, I think, or at the time of writing at least he was in Melbourne. So I might leave this book up here just in case anyone's interested to have a look at afterwards. But a lot of what I'm going to talk about today is based on results presented in this book and in several of Burkhardt's papers. Okay, so just a few interesting points, and I'd like to elaborate on these a little. Now here I've written, time doesn't start anywhere. Now what does that mean? What do I mean by that? Well, let me try and explain. When I present to you the juggling pattern 3, right, just represented by the number 3, that's not giving you any information on how I can start juggling that pattern, right? So this assumes that the mathematical juggler has always been juggling that pattern, always will juggle that pattern, and will never stop. Okay, so there are several ways. So here I've got two balls in my right hand, one in my left. So I could start that pattern this way, or I could actually start by putting all 3 in one hand, throwing them up like this, and starting like this kind of thing. So it doesn't really matter how I start. That's not important. What is important is the pattern itself. Okay? So that's the first thing. That's what I mean by this statement, time doesn't start anywhere. So we don't have a 0 point in time. The second point I've got there is that the beat frequency is not important. So in other words, when I represent this pattern number 3, so I could actually be referring to this pattern, or I could be referring to this one. Okay? They have different frequencies, but in terms of this notation, that is not important. Okay? We don't distinguish between this high frequency pattern and this low frequency. Okay? In terms of this notation, they're exactly the same. Now, we can actually have a look at some rules here. We can actually start to ask questions. Well, when can we juggle a pattern? I mean, could you just give me any old string of integers, right? Could you give me any string of integers, and is it a juggling pattern? Can I juggle it, right? And this is the sort of thing I'm going to look at now. So just to develop some of these rules, I just want to make it absolutely clear. I can develop these, or we can express these patterns in this way. So here, this just means my left hand, my right hand, left, right, left, and so on. Okay, so there is one assumption, and that is that when I juggle, I'm catching and throwing, and with left hand, then right hand, then left hand. So I'm not doing right, right, left, right, right, left, that sort of thing. Okay, there's one assumption, that I'm always doing left, right, left, right. Oh, another thing I forgot to say is I'm also assuming that I'm juggling in a two-dimensional plane. Okay, so I'm not throwing this way. Okay, I'm only throwing this way. Perhaps, I'm not sure if you could see this, but if I turn on my side, ideally, that should be in a two-dimensional plane. Okay, of course it's not. I mean, I could start to do this sort of thing, but we're not including that in this notation. Okay? So here we can see this 3 is actually going from my left hand to my right hand, or from my right hand to my left hand, and so on. Okay, so the number 3, as we've seen so far, represents a pass from one hand to the other. Okay, but what about the other numbers? Okay, what about 0, 1, 2, 3, 4, this sort of thing? Okay, well, if we draw up a similar diagram, all right, with just this pattern left, right, and so on, okay, we'll have a look. The number 2, if we cross 2 beats, okay, we end up from the left hand to the left hand again. Okay, so we can see that the number 2 in this notation actually stays in the same hand. So it could mean a throw to the same hand. Well, actually, the convention is that the number 2 just represents a hold of the ball across these 2 beats. All right, so it's just left hand to left hand, I guess the trivial throw, you might say. So what about the number 1? Okay, well, if we draw a similar diagram, left, right, we can see the 1 is just going to go from the left hand to the right hand, but we'll represent a 1 as a quick, low pass. All right, I'll hopefully demonstrate some of these throws in a minute. So a quick, low pass from one hand to the other. Yeah, I'm not sure why that is. The number 5, okay, the number 5 is a high throw to the other hand. So from the left hand to the right hand, for example. The number 4 is a throw to the same hand. And actually we also have a meaning for 0 of just an invisible ball. So let me demonstrate the invisible ball. It's really quite easy. Here's 3 invisible balls right here. So if I'm just juggling this pattern 3 and happen to drop one, I've got an invisible ball here that I'm catching and throwing. Okay, so that would be represented by the number 3. All right, and then I can, etc. Okay, so that's the invisible ball. Perhaps, well, here are some of the patterns that I can juggle, or that I can try and juggle at least. They're all 3-ball patterns. So this is just the pattern 3, okay, that we've seen so far. Right, everyone's happy with that. The 3 is just a pass from one hand to the other. Okay. Now another one, a 2, 3, and 4. Let me see if I can demonstrate a 2, 3, and a 4. This is a 2, 3, and a 4. Now I wonder if you can all distinguish between the different throws. Right, so that's the 2. The 4 is just one ball going up and down to the same hand, and the 3 is a pass across. Okay, so can everyone see that? Is that reasonably clear? A 2, 3, and a 4, just repeated over and over again. So 2, 3, and 4. Okay, maybe that one's not so interesting. What about a 1 and a 5, just to demonstrate this pattern? So remember, I said a 2 is a holding of the ball, a 4 is a throw to the same hand, and a 3 is a throw to the other hand. Well, a 1 and a 5 are both throws to the other hand. Okay, the only difference, I said in the previous slide that a 1 is a quick low pass and a 5 is a high throw. Okay, so let me just try and demonstrate, and you can see the difference. All right, so can you see the difference between a 5, which is this high throw, and a 1? It's almost not a throw, it's almost just passing from one hand to the other. So that's a 1, that's a 5 and a 1, right? Just repeated over and over again. Okay, compare that with the 3 and the 5 and the 1 and the 2, 3, 4. Okay?